Question 6. Part A. Describe fully the single transformation which maps triangle P to triangle Q. So on observation, in terms of how they're orientated, there's no reflection that's here, there's no enlargement, there's no translation, so that leaves you with rotation. So this shape here has been rotated in order to make that shape there. If you trace this and do rotations until it looks like this, you will find that a 90-degree rotation clockwise will make P look the same as Q. So that's 2 marks out of the 3. The third mark that we need for this is in order to know where we rotate about, what point do we rotate about. So for example, if I put this point here, then this triangle ends up being there. Now basically this part rotates 90 degrees clockwise around like that. How you can show this is basically when you pick a point, join a line to one of the corners and basically rotate that red shape there. So 90 degrees clockwise makes it look like this, and then we get the bottom corner like that. So sometimes you can just see it, sometimes you got to do a trial and improvement. So let me give you an example of one that's a trial and improvement. Let's say I pick this point here as being the center, so I kind of know that this is going to rotate 90 degrees clockwise round about there. So let me say I guess that point. Well, what I do is I connect this point to that corner using a horizontal line and a vertical line. Now, it doesn't matter whether or not I draw it like this or whether or not I say connect them like that, as long as I have like an L shape. Of course, what I had before was just a line. That's obviously nicer to draw, but an L shape will get the job done. And then basically what we do now is we rotate that L shape 90 degrees clockwise. So we've gone 3 to the left, that means we're going to go 3 up, and then we've gone 1 up here, which means we're going to go 1 right. So that would mean that this new corner is there. Now obviously if I draw the triangle there, it's still not exactly where Q is, but it's closer than the last point, which means this point is closer to where we need to be. Lather, rinse, repeat. If you keep going through the motions here with the tracing paper, eventually you will find this point here. And just to prove that, we have our 2 down, we have our 4 across like that, and when I rotate that 90 degree clockwise, it'll go 4 up and 2 along. There's the bottom corner. Q is exactly where it's supposed to be. Therefore, this point here is where we're going to rotate around. So 90 degrees clockwise, about 0, 0. I can see the third mark. Part B, reflect triangle Q in the line y equals x. Well, y equals x is this line here. So that is our line of reflection. You would then turn it about so that you're looking at it so that the line is going vertical basically. And from that, picking the corners of your shape, you then go across to see where on the other side it looks right. It's kind of like, I describe it as a pair of eyes. Each time I'm reflecting a point, I'm trying to think of them as a pair of eyes, and if they don't look right, then it won't be right. Like you're used to seeing things symmetrically or liking things symmetrical. That one comes over here to give us that point there, which means this is our triangle. And the question asks us to label it R, so that's exactly what I'm going to do. Done.